Okay, so continuing with our statistics chapter here, we want to talk about statistical analysis. And so part of this is measures of central tendency, which means like measuring what's happening with the data set. And these are words that I know you've seen before. One of them is mean, right? Another word for mean is average. And it's just the sum of the data divided by the number of items in the data set. That's the one I use the most. I like to look at the average score on a test, okay? But it says you should only use this if the data has no outliers. No outliers means no numbers way outside the set, which means a lot of times in a test, there are outliers, and so the mean isn't the best way to measure that data. Sorry, I'm eating some candy. Median. The median is the middle number. If you think about a road, the median is the middle of it. And so it's the middle number if you put them in order from least to greatest, or if there's two middle numbers, you take the average of them. If the data has outliers, like numbers really big or small outside the data set, but there's no big gaps in the middle of the data, then the median is a good choice. And the mode occurs the most, right? That's how I always remember it. Mode is most. And if there's a lot of repeated numbers, the mode is the best choice. And so in middle school, you talk about finding mean, median, mode. We want to talk about more than just finding it, but which one is the best choice. And so here are some examples. Oh, I should have covered this up, but that's okay. It says a new internet company has 3 employees who are paid $300,000, 10 employees who are paid $100,000, and 60 who are paid $50,000. Which measure of central tendency best represents the pay? And this was supposed to be like your thinking, and I should have covered it up, but I didn't. Think about this. If you listed about, you would do 300,000 3 times, and then 10 make 100,000, right? So you could do that 10 times, which I'm not going to write out. But then 60 make 50,000. And so it says since most of the employees are paid 50,000, the higher values are outliers, right? They're like the upper management people, whereas most people make $50,000. So it says I would have said the mode is the best choice. But it says if you have a lot of outliers, and think about the median of this would also be $50,000. Both the median and the mode of this problem would be 50,000. So that's why sometimes there's 2 answers on this. Mean would have been a bad choice because the mean would have been misleading. If you took the mean of that and you posted that and said the average person at this job makes this much money, you might think you're going to make a lot more money than you make. When you more than likely you're going to make $50,000. Look at this one. It says, which measure of central tendency best represents this data? And it's not a story problem, but looking at this, the data is really close together. Look, our highest number is 40, and our lowest number is 31. So I would think the answer would be mean here. And so let's see what it says. The mean is the best measure of central tendency because there's no outliers. There's nothing way outside the data set. So this would be an example of the mean. Okay, so notice we're not finding them. We're just asking which one we should choose. It says 2 types of measures can be applied to a set of data. A parameter is a measure that describes the characteristic of a population. One example of a parameter is the mean income of the United States. A statistic is a measure that describes a characteristic of a sample. An example of a statistic is the mean of income of the people who live on your street. So parameter is when we're talking about an entire population. So if you say the parameter of this is whatever, you're talking about an entire population. If you think about most of the things we hear about on TV and in the news is statistics because it's just a sample. They can't actually take the entire population and tell us something. So that's why we hear more statistics than parameters. And so is it a sample or is it a population? It says a company has each of its employees complete a survey on commuting habits. What do you think? Here's the key part here. Each employee, which means every employee is going to do it. So the entire population would do this. So this represents a population because every employee has to complete it, not just a sample of the employees. So what about this one? It says every 5th table in the cafeteria is interviewed to find out what students eat for lunch. Well, only every 5th table is done. So is that the entire population? No. Hopefully you said that was a sample because only a fraction of the students were interviewed. Okay, 2 more things. There's actually some math to do instead of just writing, right? Feels like geometry life again. Margin of sampling error. So when you take a sample, it says when you take a random sample, it's taken from a population, the margin of sample error can be approximated by plus or minus 1 over the square root of n, where n is the sample size that you took. If you ever see polls on TV where they polled someone about an upcoming election, it always has the margin of error at the bottom, plus or minus such and such. That comes from this, okay? So it says, in a random survey of 1,710 teens, 76% said they had downloaded music from the internet. This seems like a very old statistic. What is the margin of sampling error? So this is our n value, okay? The margin of sampling error would be plus or minus 1 over the square root of that. And so I just have some work here for you, right? So plus or minus 1 over the square root of n, where n is 1,710. And yes, that would be the exact answer if we're leaving it like this. But since we're talking about solutions here in a real world concept, it makes sense to write it like this. So this would be a margin of error, or plus or minus 0.02. And it says, so the margin of sampling error is about, we always talk about percentages, plus or minus 2.42%. This is how many said they had downloaded music, and so you want to think about adding or subtract about 2.5% to that is really kind of what you're looking when you see that. So the second part of this says, what is the likely interval that contains the percentage from the population? So they told us that 76% had downloaded it, and we're plus or minus 2.4%. 2.42%. So we're just going to add 2.42% to that, right? I think the book did it as this way, but we could do it the same way just with this, right? 76 plus 2.42 would be 78.42%, and 76 minus 2.42 would be 73.58%. So what is the likely interval that contains the percentage of population? It's just that between 73.58% to 78.42%. So I'd encourage you to go online and try to find a survey or a poll, and at the very bottom of it in small print, it usually gives you that margin of error plus or minus so much percent, and that tells you how many people they surveyed, basically. And then the last thing we're going to talk about, which we're going to do a lot more of this in class, so don't get overwhelmed by it, but besides measures of central tendency, which kind of just tells you like how close together your data is, basically, we also talk about measures of variation, all right? So it says, really important to read this here, measures of variation describe the dispersion or the spread of a set of data, which means if your data is really, really spread out, it's important to know that when you're talking about the numbers. Like, does it make sense? Is this data accurate, really? And 2 common measures of variation are variance and standard deviation, okay? This is really important here. They describe how closely a set of data clusters around the mean. Like, how close is the data to the average of the data? And so there's some new vocab here that I want to talk about, and then we'll actually do this in class. It says the sample mean, which is x with a bar above it, okay? X with a bar above it is read x bar. And the population mean is a Greek letter that kind of looks like a backwards Y almost. That's said mu, are calculated the same way. It's just the average. It just depends on which way you write it, whether you're talking about a sample or a population. The formulas for calculating the sample standard deviation, S, and the population standard deviation, sigma is like an O with a little bar out, that's lowercase sigma, are given below. So these are just equations that look really scary. The other symbol I want to show you is this. This is capital sigma, and this in math means sum. So this just means the sum of, from 1 to n, of each term in the sample minus the mean squared all over n minus 1. This is if they give you a sample data. A lot of what we're going to be doing is going to be population, all right? So population, it's the same. but now you're taking each data point minus mu, which is still the average, squared, but now you're just dividing by n. So we're going to do this in class because it's going to be better to do this together. We're going to spend a couple days on it, but I just want to kind of show you what it looks like. It says the daily high temperature in degrees Fahrenheit in a city for the first 10 days of last year were these numbers. And for the first 10 days of this year were these numbers. Find the standard deviation for the first 10 days of last year. So last year means the first ones, these, right? So step one, is this a population or is this a sample? Well, if we're finding the standard deviation for 10 days, how many days are we taking? 10 days, right? So that's the entire population of 10 days. So that's a population. And if I was going to find the mean of this, what would I do? I would add these numbers up. 3, 4, 5, 6, 7, 8, 9, 10 to 36. And I would divide by 10. And it's supposed to be 50.6. That is my mean. Or for standard deviation, we're going to say that is my mu. Okay? And then what we're going to do in class, where's my time? Yeah. What we're going to do in class is we're going to take each of these data sets and subtract it from 50.6. That's what this means. We're going to add them up and square it and divide by the number of numbers. And that will be our standard deviation. So if you want to try that, you can. Otherwise, we'll just wait in class and we'll finish this up